Hi everyone, this is Studio Digital Resin and welcome to this quick demonstration of creating a parametric stadium structure using AGX for AutoCAD. Now this is just going to be a very quick demonstration on the power of using a parametric model to create geometry that has generally a lot of repetitive elements which you can normally create using standard AutoCAD tools, but the problem with that is modifying things afterwards becomes a little bit of a nightmare or problematic. So with a parametric model, this is just going to demonstrate the power of using associative geometry with parametrics in creating such structures or structural drawings. So, as the title suggests, I'm going to try to make a copy of the Brasilia National Stadium by Castro Mello Architects. I'm going to try to do this as closely as possible. I'm not going to do any of these internal bits. I'm just going to show you the basic structural elements of the exterior and the canopy, and show you how you can do this quite quickly with AGX. Now, as I mentioned before, you can, if you wanted to, you could have quite easily created a profile, as you can see from the section of these elements, and then done a polar array copy around a vertical axis point. The problem with that is that if you ever needed to change the geometry of these basic elements, you'd have to repeat the whole process all over again, and you wouldn't be able to see your changes happening live if you needed them to happen live, whereas with AGX you can. So I've taken some basic dimensions from information off the internet of these structural elements. I'm just going to work in meters. That's going to be my units, and let's get going. So basically, they've used circles, I suspect, because this is quite a simple geometric element to create copies around circles. And they've got a rectangular interior for the football stadium, or for the pitch, but we're not going to try to do that in this demonstration. So what I'm going to demonstrate here is repetitive elements using AGX. So I'm going to just create a start point, and that's going to be our base point for absolutely everything. Don't worry where you put it for the time being. This is just going to be our main controlling point. So this point is now at 0 on the z-axis, and we will build everything up from there. So the exterior circumference, or the diameter of the exterior part of the stadium, is 308 meters apparently. So I will create our first circle by center point and radius. Pick a center point, enter a radius, which will be 154. So this will be the exterior radius of the stadium. So that's this exterior circle here. Now I'm going to create the flooring. This is apparently 22 meters, the distance between these. So I'll create another circle, center point and radius, and that radius will be 132. Right, so now that's given us the base of the, I suppose, the first floor walkway. I'm not going to go and show you below this for the time being. Now these pillars are apparently 36 meters high, so we need another circle to define that top level circle. So we'll create another one by center point and radius. Now I'm just going to enter a radius that's slightly larger so that I can select it otherwise it's going to plonk directly on top of the other circles and selecting might become a bit difficult. This will be fixed. So I'll put 156. Right, now I'm going to go to my control panel, select this circle, change the Z offset to 30. No, my mistake, it's actually 38 meters, I believe. Enter, and put this back down to 154. Right, so that's the high level exterior circumference or diameter. Now I'm going to create another circle, which will be the same radius as this one, which was 132. So I'll just make it 130 for now. Select it. And I think that this one is probably 2 meters below the outer one. So that would be 36 meters. As we can see from the image, this circle here is clearly lower than the outer one, so that water can run down. And then it runs down towards here, so it means that the circle on the outside here is obviously a little bit lower. And then there'll be another circle over here, which is slightly higher, so that it runs down into the center point here, and I suspect that somewhere along this line there'll be some drainage points. Okay, so the canopy will extend 82 meters, which will give us a radius of the smallest circle of 50 meters. I suspect it's 50 meters. So I'll create another circle. Center point and radius, choose our center point, 50 meters. Now this one was at 36 meters, I'm going to make this one say 35 meters. If we go to our side view, we can see that we're going to get a slight slope down towards the end. Now actually this, I believe that this is the total canopy extension is 82 meters. So this bit here is probably, say, 10 meters. So I'll have to create another circle that is 10 meters larger than this one, and then raise the height of this one again. So I'll create another circle, center point and radius, and I'll make it 60. Let's change the height of this one to 35, and I'll come back to this one and I'll raise your height to 36 so that we have a slope. Right, now these circles are important because they formulate the host for other elements to equally divide so that we can create the truss elements. Now I counted that there are 48 bays on that particular stadium. So we have to subdivide all of these circles 48 times to create the geometry that we need to repeat. So we'll create a GX point. By bays on curve. I'll choose the first one. Number of bays is 48. Include the start point, yes. Include the end point, no, because we don't want the points to overlap. And there you go. This circle has now have 48 bays, and we'll just do the same for all the rest. 48. Yes. No. Repeat it again. Eight. Yes. No. Choose you. 48. Yes. No. Right, so now we've subdivided each of these top-level circles by the number of bays that we need, and we're going to have to attach lines to create our trusses. Now, this truss here, I suspect that this depth, I don't have these figures, but I'm just going to say that this one here is 2 meters, this one here is 4 meters. So we need to create another circle, which will define this inner circle here, 4 meters below that one, and another one 4 meters below this one. So this circle has a 60 meter radius, it's at 35 meters, so we'll go to 31 meters. GX circle by center point and radius, center point 60, change its Z offset to 31, so that should now be 4 meters below the circle above it, and we've got to repeat this one 2 meters below. So what was this one's radius? 130. So we create another circle by center point and radius, 130. This one has to be 130 as well. Okay, so now we need to subdivide these two new circles again with 48 bays. 48, yes, no. And do it again by bays on curve. 48, yes, no. Okay, so now we've got all our points we need to start creating the lines necessary for the top part of the structure. So we go to GX line, by start and end point. I'm going to move inwards. Choose this point and this point. Don't worry about these figures, I'll explain all of these later on. AGX knows how to handle the attachment of the points or the lines with their points. I'll repeat the process, start end point, choose this point and this point. Repeat the process, start and end point. And we have our points. Okay, so now we've got the top part of the profile. Let's create the truss. From there to this point. And you can see the basic shape of the truss now starting to appear. And I think there is a line going from there to there as well. I'm just going to do a straight line for now. I know it's slightly different on their design. From there to there. And that defines the profile of the inner canopy. And I think there is one as well. From there to there. Okay, now this truss has got 8 bays. So now we're going to repeat the process with the points. We're going to subdivide each of these lines by bays. Click on the curve. 8 bays. Do we want to include the start point? Yes. The end point? Yes. And now it has subdivided the top lines with points. And we'll do the same for the bottom line. 8 bays. Include the start, yes. Include the end, yes. Right. So now we've got to create our truss members. Now these trusses have a diagonal and then a vertical straight down. So there's two ways, well there's one way you can do this at the moment, is if we choose GX line by start and end point. All of these points here will be our start point, and all of these top points will be our end point of the line. Now this is where you can use the start and end skips. So we don't want to skip any start points, but we want to skip the top point. If you didn't specify any values, then it will go straight up, but we want it to go diagonally. So start point is 0, skip, end point, skip, 1. And what that will do is it will create all the lines joining the points as you've specified. Now to create a line vertically down or vertically up, we just do the exact same thing. Start and end point, start point, end point, and we use the defaults 0 and 0. And there we go, we have a replication of the truss at least. Right, now for the columns. So what I'm going to do is I'm going to subdivide each of these lines by 3 bays because there's 3 columns. Actually, what I'm going to do is I'm going to subdivide it by 5 and leave the start and end points. I'll show you what that results in. 5 bays. Include the start point? Nope. Include the end point? Nope. What that does is it doesn't put a point at the start point of the line. So you only get points on the inside of the bays. And I've got 1 bay too many here now. So I'm just going to go and change that point to 4. So now we can do 3 lines going vertically down. Purely because on their design they've got a bit of a lip coming out, offsetting from the last column, and the inner column doesn't actually join the main structure. But that's not really that important, just for demonstration purposes. Right, so now what we need for joining the lines here to a line down at the bottom is we need another point. So we're going to have to just repeat the points again. By bays on curve, we choose this curve. Circles are curves, 48 of them. Include the start point, yes. End point, no. And repeat the process again. 48, yes, no. Then we draw a line by start and end point. Now I'm going to subdivide this line the same way as I subdivided the line above it. 4 bays, nope, and nope. Now I'm going to draw a line from start and end point. So one of these points and a point below it. We don't want to skip anything. And there we have our vertical columns. And there you have it, basically. I've got to sort out the size of these points. For some reason AutoCAD is just not regenerating them properly in perspective mode. But if I go back to parallel, and we can see that we've taken a little bit longer to create this than I did in the practice video. But there you have it, essentially. Now these are just the unsolid lines. I mean, these are just lines and circles. This defines the base geometry of the structure. I mean, but if you wanted to see it in a little bit of a more three-dimensional manner, you could attach a surface to say there from there. Let's change the view quickly. Let's go to X-ray. Do the same thing down here. Now, in the future versions of AGX, you will be able to do this using AGX. You'll be able to create surfaces and three-dimensional objects from AGX entities, so that you don't have to keep on attaching surfaces to current AutoCAD entities. I mean, this is an associative surface, so if I had to modify any of this geometry now, the surface will change with it. But if, for instance, I wanted to create a surface between this one and repeat it, then I have to do it one by one, whereas with AGX it will do it all automatically for you. And there you have it, basically the same sort of structure as the Brasilia National Stadium, minus all the time to explain in about 10 minutes. Hope you've enjoyed watching, and see you again soon.